Valles caldera exists here because it sits at the intersection of two major fractures in the Earth's crust: the Jamez lineament and the Rio Grande Rift. The Rio Grande Rift stretches from Colorado south into Mexico and is a place where the Earth's crust is thinning and moving apart. The cross-cutting fracture, known as the Jamez Volcanic lineament, is a series of connected volcanic centers running from southwest to northeast. Geographically, it starts in eastern Arizona and runs diagonally through Mount Taylor, the Valles caldera, the Taos volcanic field, and then ends at the Raton volcanic field in northeastern New Mexico. The Valles caldera is located at the intersection of these two fractures. Its unique location caused the Valles caldera to erupt for the longest amount of time and to create the largest amount of volcanic material erupted by any of these volcanic centers along the Jamez lineament. Research shows that volcanic activity in the Jamez Mountains began about 14 million years ago. From the beginning, this was a nest of small volcanoes. For 12 million years, these small volcanoes erupted, forming the Jamez volcanic field. Lava flows and volcanic domes created a complex landscape of ridges and valleys. As these eruptions continued through time, magma from the Earth's mantle continually forced its way into the surface crust of the region. The result of this constant flow of magma is that the individual magma chambers began to melt together into one giant magma chamber. 1.6 million years ago, this giant magma chamber erupted, forming the Toledo caldera. This eruption spewed out 95 cubic miles of ash, molten rock, and superheated gases called pyroclastic flows. These flows roared out of the eruption centers at speeds up to 200 miles per hour and temperatures of up to 500 degrees Celsius, obliterating everything in its path and forming the lower Bandelier Tuff when they cooled. The lower Bandelier Tuff covers an area of 85 square miles in New Mexico to a depth of hundreds of feet in some places. The eruption columns formed by the Valles-Toledo eruption rose 20 miles into the atmosphere. Winds spread the ash as far east as the Arkansas River in Kansas and Oklahoma. 400,000 years after the Valles-Toledo eruption, the Valles caldera eruption occurs in the exact same footprint. Thus, we have two caldera-forming eruptions within 500,000 years, one obliterating most of the evidence of the other. Something to consider is that the Mount St. Helens eruption in 1980 ejected about half a cubic mile of ash. This amount of ash would fill the Superdome in New Orleans 286 times. The amount of ash erupted by the Valles caldera is 75 cubic miles, or enough ash to fill the Superdome almost 86,000 times. 200,000 years after the Valles caldera eruption, a more fluid magma began to rise in the magma chamber. Lava oozed out in a toothpaste-like eruption to form the small mountain called Cerro del Medio. These small volcanic eruptions have continued to occur around this central ring about every 50,000 years. The most recent eruption occurred at the Banco Bonito lava